The interplay between temperature and material durability is a critical consideration in engineering and science. Good day, everyone. This presentation explores the relationship between increasing temperature and the durability of steel, utilizing Newton's law of cooling as a framework to analyze the thermal dynamics involved. With our chosen scenario to model, heating of steel due to fire. Let us examine how increasing temperature impacts the structural integrity of steel.
I am Francine Silansaderas.
Equation and its solution. The method we use to solve the differential equation representing Newton's law of cooling is variables are above. We first separated the variables by moving all terms involving temperature to one side and all terms involving the time to the other side. Then, we integrate both sides of the equation. The resulting equation involves a natural logarithm, which we can solve by taking the exponential of both sides. So therefore, t of time is equal to c prime e raised to negative kt plus ambient temperature. This formula determines the temperature T at a certain time.
Finding C prime. Suppose that the initial temperature is TO, which is the temperature at time is equals to 0. So TO is equals to C prime E raised to negative KT plus the ambient temperature. So we get that C prime is equals to initial temperature minus ambient temperature. Substitute the value of the C prime from the earlier equation, we get that T of time is equals to the quantity of TO minus the ambient temperature times E raised to negative KT plus the ambient temperature.
I am Micaela Maria D. Manliquez. Moving on to the problem of the discussion, it states, a fire started in a building that increased the temperature up to 600 degrees Celsius, where a certain steel coated with 3 centimeter thick concrete reached 350 degrees Celsius in 60 minutes. Suppose the 3 centimeter concrete coated steel had a room temperature of 38 degrees Celsius. Find its increase in temperature over time.
So in solving the problem earlier, we have the given of initial temperature equals to 38 degrees Celsius, ambient temperature 600 degrees Celsius, and a T of time is equals to 350 degrees Celsius in a time of 60 minutes. Using the equation earlier, you just have to substitute these given values at that equation.
Substituting the initial values, we get that the temperature or particular solution at time t is T of time is equals to negative 562 degrees times E raised to negative 0.0135 T plus 600.
This graph shows the relationship between temperature and time of steel induced by fire. The curve indicates how the steel's temperature changes over time. Key observations is that rapid increase in temperature. In the initial phase, the temperature rises sharply. This is shown by the steep upward curve, suggesting that steel heats up quickly when exposed to fire.
Heating of steel due to fire. It is a significant thermal scenario in civil engineering because it directly impacts the structural integrity of buildings. Steel becomes less stiff and strong as temperature rises, which could result in disastrous failures. Its relevance to civil engineering is that engineers can create safer structures with suitable fire resistance measures and ensure public safety and adherence to building rules by having a better understanding of this scenario.
Hello, I'm Hans. First thing is to determine an equation that calculates the change of temperature over time, where we assume that the initial temperature of the material is 38 degrees Celsius and the ambient temperature is 600 degrees Celsius and the temperature at time t is 350 degrees Celsius in 60 minutes. To be more realistic, the data provided came from the previous research where the data used is eligible to calculate the change of temperature over time to the stated problem. How might heating process affect the structural integrity of the material? In the scenario of heating the steel due to fire, the integrity of material is significantly affected, whereas the relationship between temperature and steel strength is inversely proportional. As temperature increases, the strength of a steel decreases.
Moreover, due to increasing temperature, the steel may experience uneven contraction that can lead to the following: 1. Warping, distortion in the shape affecting the alignment and load distribution. 2. Residual stress, leaves the structure more prone to failure. 3. Brittleness, this may lead to fractures. And 4. Decreased hardness, leaving the structure more prone to wear or deformation.
I am Hasmer Khalil A. Madihanon. The heating rate of a steel beam exposed to fire is influenced by various factors, including the heat flux from the fire and convective heat transfer. To accurately model the heating process, it is necessary to incorporate these factors into the equation for Newton's law of cooling. By adding terms for heat flux, which is Q of T, and convective heat transfer coefficient H, the modified equation becomes d temperature over d time is equals to the negative K constant plus Q of T minus H times to the constant. These equations allows for a more comprehensive analysis of the heating of steel beams under fire conditions, considering the dynamic nature of the fire environment and the complex interactions between the fire, steel, and the surrounding air. The heating of steel in a fire affects its durability, as explained by Newton's law of cooling. High temperatures can weaken steel, compromising its structural integrity. This highlights the importance of understanding this relationship for designing safe buildings. Let's continue to bridge theory and practice in our pursuit of excellence in civil engineering. Good day to everyone and goodbye.